live. It's happening. How's it going? What do we got going on here? A little, today I'm going to be doing an analysis on read ahead. Read ahead is something that I talk about a lot from the perspective of optimizing Cassandra performance. And really just database performance in general. I mean, any database that isn't doing direct I/O can be impacted by this because of the way read ahead works. So basically, what read ahead does is whenever your software does a request to the file system, the first thing that happens is that it's essentially preempt. Like your read doesn't really just go to the file system. It doesn't just go to disk right away. It gets intercepted potentially by the page cache. And so if the read can be satisfied out of page cache, cool, everyone's happy. But if we can't satisfy the read out of page cache, the OS will go ahead and read the data off disk, and it will read a bigger block. It will actually read what's called read ahead. So it performs the read ahead, it reads the large block, puts it in page cache, and then you get your result out of the page cache. So it's first it brings it into page cache and then it returns the result. And this is kind of cool if we were dealing with really slow spinning disks, okay? But the problem with doing it with a database is databases do a lot of I/O. And if you're not using those additional pages, all you're doing is you're putting additional pressure on your disk. And so I always recommend people decrease their read ahead settings considerably. If you're using local storage, like if you're using NVMe, it's a really good idea to just go ahead and disable it altogether or set it to 4K, because 4K is really the minimum that you're going to be able to read anyway. However, there is kind of an open question. Well, what happens if we're using EBS? And the reason why EBS is so specific to this question is because EBS measures EBS has a built-in throttle. So you're not actually dealing with the underlying limitations of your hardware that degrade over time, that have kind of a nice like curve to it. You kind of just hit this wall, and they don't make it easy to understand when you hit that wall. So I'm gonna take a look, and we're gonna hey Sarma, we're gonna go into what's actually happening here. I'm gonna bring up my terminal. I'm gonna bring up my browser. Honestly, this is probably not going to be the most exciting thing in the world because I'm going to get stuck in a few places as I leaf through the manual. But feel free to ask questions. This is one of those topics that I find really interesting, and so I'm using this as an opportunity to kind of gather information before I write a blog post later on. That's a lot more detailed. As to how things work and diagrams and all the good stuff that you're probably interested in seeing if this topic interests you. So I'm just gonna switch over here. I have a terminal that I've been working with already. I'm not sure. Whoops. Hopefully that's big enough. So what we have here is this. Okay, when we look at block dev report, this is a really useful bit of information, and block dev report tells us a handful of things. The most important for this subject is going to be this column over here that says RA. So if we look at the manual, and I'll just bring it up right here. You're going to see that RA, whoops, no, read ahead, okay. Get file system read ahead in 512 byte sectors. get it into 512 byte sectors. So this is kind of silly because it's not obvious that it's in like half of a K. So you really just need to divide this number by 2, because 256 read ahead sectors is 128K. So important to know. Where was it? Yeah, still here. It's always in sectors. Weird. So you end up getting it in kilobytes. This is just to get it in kilobytes, just divide by 2. So I have a file here called this FIO test that I started working on before I got started here, because it's kind of weird. I'm gonna see if this works. I actually was having I got kind of an error with this, so I'm not sure if I have an old version of FIO on here, but let's see. What's my problem here? All right, big read. You need to specify size. Oh yeah, I forgot to do that. What was I doing? Did I have it open somewhere else? Nope. Let's just go with it anyway. Okay, we'll just put size here. Oh, I remember. I was going to put size. So this just to switch over for a sec. This is I've resized this volume. So this is a 50 gig volume, and it's set for 5,000 IOPS. Now with GP3, you can independently set the IOPS, but you can't do it with GP2. So GP2, the number of IOPS is going to be proportionate to the size of the volume, and with GP3, you can change them independently. You can see that if we were to go over here, we could just go ahead and adjust this size, and I probably will adjust it just for the sake of being thorough. So just going back over here, let's see if this. So if we run this with so originally we have a 50 gig size here. So let's just go ahead and do this at 30 gigs. So we also don't have a ton of memory on here. So this box, we basically have just shy of 8 gigs over here. And we're not really using much for anything. This is a brand new instance that I actually just spun up from an AMI that I have here that can actually, it's kind of cool. I'll just talk about this for a brief second. I'm in the middle of working on this this project that has a Packer file. You can use this Packer file to generate an AMI that has multiple major versions of Cassandra on it: 3.0, 3.11, 4.0, 4.1, 5.0, and BCC tools, which is a really nice package that unfortunately doesn't install correctly sometimes with in AWS. I don't know what the deal is, but there's something wrong with it. I had to recompile from source so that all this stuff is built in. So it compiles that, it downloads all the versions of Cassandra. This is actually going to be probably the same tooling that I use in the training program. So if you're interested in kind of taking a look at this, it's in my my GitHub repo at TLP cluster. Anyway, so this is just some of the stuff that gets put on here. So you get BCC tools, FIO for measuring disks, things like that. So now if we were to run FIO test, so let's just see what this guy does. So this is gonna lay this out. It's probably gonna error out. I'm not. So if we look at if we look at the config now, this is set for random read with 4K blocks. And so this should do them. I hope this does them sequentially. Otherwise, it's really not very helpful. I'm just gonna make sure that these jobs are sequential. Let's see. So while it's laying it out, let's just do this. Oh, come on. That's a giant mistake right there. So this is actually a good opportunity. So I'm just going to let this run in the background, and I'm just going to jump over here to my IDE. So I've got. So this is the project. So TLP cluster is what I started with. TLP cluster though has some issues, like you can't have it run multiple versions of Cassandra, right? I originally was going to make this so that it would do a build of each version of Cassandra that I could use, and then I realized it actually just makes more sense to have one mega image with all the software I could ever possibly need on it. So like here where I'm, installing wget, here I'm just going to make it so that I also install FIO and systat. So now the next time I use this, this will already be here. Back to terminal. So it's still laying this out, but now we should be able to take a look at IOStat. Okay, IOStat, just doing writes per second. It looks like it's in the 500. So here's the interesting thing here. So this is doing only 500 writes per second, right? But this is a 5,000 IOPS box. So, it becomes a question of like, why is it doing that? Is it because it's only from a single thread, or are we actually being throttled on the AWS side? So if I go back to AWS here, and then we go to monitoring, right? So this is kind of interesting because we might be like, why? What is the problem here? Like this doesn't show us that there's actually anything going on, right? Even though this is, let's just leave that open. Even though that we have writes going on right here, it's not showing them. And IOStat is actually showing me, if we look here, IOStat is showing me that we're getting, 66 megs a second, but you don't see that over here. So what we end up doing is we have to go over here and then let's just make this like 1 minute. Let's see if we can get something. Am I in the wrong volume? I could be on the wrong volume. G50 monitoring. So you see how this is kind of this is what makes it difficult sometimes to use AWS, because you don't end up seeing some of these numbers. Like, why do I not have like higher throughput showing on here? It doesn't always make sense. So sometimes let's see. Like, why do we not get it here? still not there. So weird. Right? And then you never see it. Dicey. So I'm not sure. I've encountered this type of issue before where I don't always see this. Let's just make sure I'm hitting the right one. Oh, whoops. Okay, so that's kind of weird. We got 60. Oh, I see what it did here. Okay, so we've got 30 gigs. So what did I have it at? 30 gigs. Oh, I see. It's because I have my two things. Hold on. Job. Okay, so here's what we're gonna do. We're actually gonna do this. Yeah. Yeah, I think for right now, the tricky thing for me is that I haven't used FIO in a couple weeks. All right. So we're just going to go ahead and get rid of this direct test. This is, get rid of this one. So we're just going to have a single test, and we're gonna modify it as we mess around. There's a threads. There's a number of, we can actually have it use more threads, which is probably going to be what we're going to want to have. Or we can, I think it's jobs. Num jobs. Here we go. All right, let's see what happens when we do this. And no, we're not going to do that. Yeah, let's see what happens. We have 10 files, 10 gig files, 4 jobs. Oops, what did I do wrong? No job defined. Let's just call this do reads. so while that's doing that, we're going to once again take a look at IOStat. So now, let's see. So with more jobs writing this out, we're still only seeing about 500 writes a second, which is kind of interesting. I'm curious. Let's see. Okay. So this is actually a useful bit of information. So this the write average request size. See how this is 128. This is because it's writing at 128K blocks. So this is really one of the important things about EBS. So EBS is going to measure the number of IOPS. I believe it's measuring it in 16K blocks. So as soon as we start using 128K, it's getting a it's 8x. It's going to cut the number of actual operations that we can do by 8, right? So if we have some high number of IOPS, like with this volume, it's 5,000. You can see here that this is at 528. So if we just do a little bit of math here, 528 times 8 is 4,200. So that starts to butt up against the limits of the underlying IO configuration. So once this is all laid out, we can go ahead and this will run and do its read load. But if we do, oops. So I'm going to switch to root here, and then, oops. So we have this program called biolatency that I've talked about a few times, and just make this bigger. Biolatency is really cool because you can take a look at the underlying, like the performance of the underlying. Let's see, here we go, read ahead. Laying out. What did I do? I probably didn't need to give it that. Actually kill that and restart it. Unfortunately, using FAO is a very iterative process. It's an awesome tool for modeling like any type of workload on disk, and this is kind of my go-to. I'll be honest, like one of the worst things that you can do is just take what you see from your database and just kind of make assumptions about the underlying hardware. You can get some incorrect information that way. That's one of the reasons why whenever I talk about performance, I always talk about the use method. And then, so like for example, like here, so if we do biolatency, so what this does is this traces IO, and you can see here that we actually we're hitting definitely an IO limitation. All the requests are taking forever, and so basically what we know here is that we're butted up against the limits of the IOPS on the machine, because these requests shouldn't be taking 32 milliseconds. This is just way too long. That's what we're seeing. So usually, or in the past, I've been able to, I'm going to switch back to my AWS slide here again. Let's see if I can get this thing. Yeah. So in the past, I have been able to use under this monitoring tab, if you go to the read operations or write operations, in this case, we expect to see the write operations. So if we want, whoa, not cool. Did not work. Why don't we do, let's see. Oops. So bio pattern, we want to see, hey, welcome back. Let's just see what happens if we do this. So you can see here, bio pattern is really cool because it tells us at any given like moment in time what is kind of going on your disks. So you can see here there's some random operations, but for the most part we're dealing with sequential operations over here. Okay, now it's going to the next one. So I put 4 jobs in here, so it does all of them. I guess it's going to lay them out separately. Let's see. And I expect that when we look at cache stat, we're going to see that this is going to be really low because we're not doing reads, right? We're just blasting this thing with writes, and it's going to not really be able to do much of anything. But once these reads start, what we're going to do is take a look at the file system. So we're going to use XFS. There's XFS slower, which is a really nice command, and there's also XFS dist. Okay, so we're gonna take a look at XFS dist as we do this right here. So XFS dist, we're gonna say we're gonna run every second, and we're gonna do 30 iterations of it, and let's just see what it tells us. Yeah, so this is pretty cool, right? This is what we want to be able to see. So we're gonna isolate this now. I've had this crash on me before. Let's just go with just the process of FIL. And then we get this, XFS dist. Let's see if this works. Excellent. Okay, so here's what's cool here. We can actually break down the performance of our writes. You can see here. Whoops, you can't see it. So the performance of our writes is over here, and for the most part, we're actually getting pretty decent performance on the writes. And the interesting thing about that is that writes actually happen at the because writes happen at the file system level. When you do a write to the file system, it's backed by the page cache. And then it's a file system is essentially, unless you tell it explicitly to flush, a file system is a write back cache. You write to it, and when it thinks it's a good time, it will go ahead and page it out. Now we can do this automatically. We can actually take advantage of it. But the reason why I like looking at this is because when we take the file system, we can compare it to the let's try bio pattern. Okay, so what we saw here was that these write operations were taking like 0 to 1 milliseconds, right? But when we go here, when we look at bio latency, let's see if it breaks it out. Okay. See how this is really slow? So this is basically what we can see here is that the file system is really fast, right? The file system allows us to do the write, but not necessarily wait for it to be flushed to disk. And then we go over here and we take a look and we see that our write patterns are to the drive themselves are not particularly great. right? In fact, almost all of it. So this is all being synced in the background. Let's see. There we go. Now you can see it all. Okay, so hopefully this is clear. This is sort of the way that we can differentiate between the benefits that we're getting out of page cache and the performance of the page cache and the file system versus the page cache of versus the performance of the underlying device. They're not the same, and so this is one of those cases where it's like trying to understand what the benefit is of serving reads out of page cache. It is significantly improved when you use when your application is able to make effective use of page cache. You can see it in the numbers that I just showed you. Now it looks like, let's see. So it looks like this finished up, but it didn't really do. Oh, we ran out of space, of course, because I'm an idiot. Let's do CBS. Yep. Okay, so I need to get rid of that. Okay, now the cool thing is that when I start this over, nope. What happens? Oh, it might be, why did they quit? Do reads latency. It probably is because I told it not to go above a certain latency. So let's just take a look here. Latency target 10 milliseconds. Nope, get rid of that, get rid of that. And let's see what it does. So this is going to give us some like terrible numbers probably. It's going to lay out the job files in the same way, but it's actually going to be able to use the ones that we have. So this is currently doing. You can see that we're getting 30,000 IOPS per second here. But the thing is that this is going to be correlated to the. There's a couple things that are important here. One, what's our page cache hit rate? So here we can actually check that out with a tool called Cache Stat. So let me just make sure you can see this. So here's the interesting thing about Cache Stat is this tells us what our page cache hit ratio is. And right now, because this file, like these files just have been laid out and they're randomly being read from, so we're not really going to get a great, or under most circumstances, we're not going to get a great page cache hit rate. Now, we're actually not seeing very many requests actually go to the page cache. I'm not sure why are we not seeing misses here. Do we have this on? Okay, so this is not direct. Why are we not seeing? Let's try this again. Okay, so what we should see, let's just take a look at our file system. XFS. Okay, so we're going to take a look at XFS slower. This is a pretty cool tool. So once again, we're going to look at FIO, and we can see here this is the original process. And it just has the lowest number, so it's the easiest way to tell. So we're going to do XFS slower. Okay, we're going to only look at this process, and we're going to take a look at requests that take longer than 5 milliseconds. So let's just see what happens here if we get any on the file system. What is going on here? How is this so fast? Did I do something wrong? So when we look here, we can see that this was actually doing some stuff. And do reads, IOPS 7,000, bandwidth 29. So let's just see how this compares to the screen. So 7,500 IOPS, 29 megs per second. And then this volume, whoops, over here. So this one was configured for 5,000 IOPS. So it's interesting that we're seeing more than that. Maybe maybe that's because I switched away and didn't give cached out enough time to port back. Let's take a look again. Okay, why are we not seeing anything get reported in here? Starting for processes, go ahead, it's doing its reads. We should be seeing stuff. One of the interesting things about this, or maybe not interesting, one of the least interesting things about this, is that it's a lot of just kind of trial and error. It's a lot of just looking at the screen, seeing if I can figure out what the numbers are telling me, and running things many times. Like, I definitely do not get these configs right the first time or the first 20 times. So if you're interested in kind of like, trying to replicate this sort of thing, don't feel as if you need to get it right away. It's basically impossible. You have to do a lot of these, and you have to keep running these utilities to understand what's going on. Like, I can see right now that I've got a ton of requests coming through at the block device level. And then if I want to XFS, let's see. Let's just do XFS dist. Let's try 1 second. Let's try 30 seconds of this. Let's see what we got here. Okay. So we see our distribution here. This is still pretty great. So we're not actually seeing it hitting the limit. Right? There's like a couple outliers, but these never really go. Like, here's one above a millisecond. So if we're seeing most of these requests come in under a millisecond, and we are seeing at the block level we're definitely seeing that at the block level. So even though that this is, so why are we not going to page cache? It's probably the IO engine. Probably want to switch up the IO engine here. Okay, so that is not what I want to see. So what I want to see is oh, come on. See what kind of IO engine we'll use. Let's see what's available. Okay. Let's just switch to this guy. So this should immediately go back. Yeah, shouldn't have to rewrite anything. Good. Oh, come on. Okay. It's weird that I'm not getting those stats, but I'm seeing the page cache increase. Why is that happening? Should be at least be seeing misses on there. Okay, should definitely not be seeing it now.